Let's look at a special application of the intermediate value theorem, the intermediate value theorem for zeros. So we let f of x be a continuous function on the closed interval ab if f of a and f of b have opposite signs, or if either f of a equals 0 or f of b equals 0, then there exists at least one real number c in the closed interval ab such that f of c equals 0. And you can see a nice visual of it here. So let's look now at an application of the intermediate value theorem. We're told here to use the intermediate value theorem to show that the polynomial function f of x equals x cubed plus 2x minus 1 has a 0 in the closed interval from 0 to 1. So what we want to do first is find f of 0 and f of 1, because we're trying to determine if they have different signs. So f of 0 equals 0 cubed plus 2 times 0 minus 1, which just equals negative 1. So notice that f of 0 is less than 0. Now let's find f of 1. So we have f of 1 equals 1 cubed plus 2 times 1 minus 1, which equals 1 plus 2, which is 3, minus 1 is 2. So f of 1 is greater than 0. So since f of 0 is less than 0 and f of 1 is greater than 0, somewhere between the points 0 and 1, there must be a 0. But we want to write that out formally. So we write, since f of x is a polynomial, it is everywhere continuous. So then, it is continuous on the closed interval from 0 to 1. Because f of 0 is less than 0 and f of 1 is greater than 0, we can conclude by the intermediate value theorem, and I'm just going to put IVT, that's a standard abbreviation for intermediate value theorem. So we can conclude by the intermediate value theorem that there exists a c in the closed interval from 0 to 1 such that f of c equals 0. So let's read back our proof and see if it makes sense. The proof reads, since f of x is a polynomial, it is everywhere continuous. So then, it is continuous on the closed interval from 0 to 1. Because f of 0 is less than 0, and f of 1 is greater than 0, we can conclude, by the intermediate value theorem, that there exists a c in the closed interval from 0 to 1, such that f of c equals 0. And that concludes our proof. We could further validate our conclusion by looking at both the graph and the table. If you want to use a table to identify any zeros, what you do is scroll down the y values and see if you see any changes in sign. Notice about halfway down our table that we have a y value of -1, and then all of a sudden we have a +2, so it jumps from -1 to +2. So once you identify the y interval where there's a change in sign, then you look over to the corresponding x values to identify the closed interval that contains the 0. So in our case, the closed interval is going to be from 0 to 1. And then looking at the graph, it's pretty obvious that we have a 0 right here, c, that's between the x values of 0 and 1. Now it's time for you to get some practice using the intermediate value theorem. For this, you try it. You're asked to use the intermediate value theorem to show that the polynomial f of x equals x to the fourth plus 2x cubed minus x squared plus 1 has a 0 in the closed interval from -1 to 0. So please pause the video and see if you can formulate a proof. Remember that you want to put the proof in your own words. When you're ready, you can unpause the video and compare your proof to mine. So what I did first was find f of -1 and f of 0. And I found f of -1 to equal -1, which is less than 0. So f of -1 is less than 0. And I found f of 0 to be 1, which is greater than 0. So f of 0 is greater than 0. So by doing that, I verified that there was a sign change between f of -1 and f of 0. I also noted that since this is a polynomial, that it's continuous everywhere, including the closed interval from -1 to 0. So then I was ready to come to the conclusion that there must be a 0 in the closed interval from -1 to 0. So here's the write-up of my proof. Since f of x is a polynomial, it is everywhere continuous. So then, it is continuous on the closed interval from -1 to 0. Because f of -1 is less than 0, and f of 0 is greater than 0, we can conclude by the intermediate value theorem that there exists a c in the closed interval from -1 to 0 such that f of c equals 0. And that completes my proof. I also included a table and a graph to show my results. When we look at the y column of the table, notice that there's a sign change from -1 to 1. While the corresponding x values are -1 and 0. Because there's a sign change from -1 to 1, that lets us know that there's a 0 in this closed interval from -1 to 0. And then we can also verify our conclusion by looking at the graph, and it's pretty easy to see. Between x equals -1 and x equals 0, we have a 0 on the graph. And that's because there's a sign change on the y values. F of -1 equals -1, but f of 0 equals 1. so that causes us to move across the x-axis. Well, that brings us to the end of our lesson. I'll see you next time.